This is my great pleasure to introduce you to Daisy, who is the director of the Statistical Community of Practice, and she will tell us all about what we did. Taking on.
Thank you. Right, now let me just try and share my screen. Okay, hello everybody. Thank you very much for attending while you have your lunch. Yes, I'm Daisy Powell. My regular job is at the Institute of Education, though I'm actually a psychologist by background, but I've been working here at the Institute of Education since 2012. And for the last couple of years, I've also been working as the director of the Statistics Community of Practice, or SCOP, at Reading. Okay, so today the plan is that I'm going to start really much more broadly by talking about how statistics really fits in with the open research agenda. And then I'm going to move on to telling you about the statistics community practice. Okay, so to start with statistics and how it fits in with open research. As we're going to be hearing a lot this week, open research is really defined by transparency, accessibility, and reproducibility, and making research as reproducible as possible. And there are lots of different types of practice, all of which I think are going to be covered at different times this week. So pre-registration, open data, open code, open source software, open access publishing. But why should we care about statistics, and how does statistics fit in with this? Now, one of the main reasons that we know we've got to care about statistics relates to the reproducibility crisis. As you'll know, over the last decade or 2 decades, it's become clear that the way people have used statistics has been a very important contributor to the reproducibility crisis. So one of the first papers that really drew our attention in the psychology field to this was published in 2015. And this paper, published in Science, showed that when a group of researchers tried to replicate, I think it was 100 studies that were published in really key papers in key psychology journals, quite astonishing. It was astonishing that only about a third, so I think it was 36%, they managed to actually replicate the findings of those studies, which was very shocking. But it's not just psychology. I think this soon impacted social sciences more broadly. And in this paper that I think was published in 2018, it was shown that even research published in the top journals, Science and Nature, only 60% of those were replicated when people did try and replicate their findings. And it moved broadly across the sciences as well. This paper addressed the issues in biomedical sciences, and to quote the author, a string of 5 articles and an editorial printed in The Lancet in early 2014 addressed this issue of reproducibility, reaching the staggering conclusion that 85% of biomedical funding is wasted because of these issues around robustness and reproducibility. Of course, it's not all about statistics. Statistics isn't the only reason why research might not be reproducible. But it does play a big part. And one of the key reasons why it plays such a big part is the fact that everybody relies very heavily on p-values. Now, I'm pretty sure everybody here knows this, but I'll just remind you that, there's this our golden value of 0.05, the threshold that we all try to achieve in our statistics, because that allows us to say that what we found is statistically significant. What this actually means is that we can reject the null hypothesis. So if we were looking at an intervention to increase something I'm interested in, early language skills in preschoolers, and you compare your preschoolers with the control group, the null hypothesis is that your intervention is going to have no effect whatsoever and that there will be no difference between your groups. But if, when you get your test statistic, you find a significance level of 0.05, that tells you that if the null hypothesis was true, it would be incredibly unlikely. In fact, there'd only be a 5% chance that you would have got that result. So you can reject your null hypothesis. But, obviously the problem with that is that that's the probability of getting that finding if the null hypothesis was true. So that tells you that there is a 5% chance that you would have got that finding if there was actually no effect. So that's already a problem. And if you then run hundreds of statistical tests when in that paper that you're describing your research, there's a very, very high probability that you're going to start making errors of inference. Plus, p-values are extremely unreliable, and they're particularly unreliable when you've got low statistical power. And this is really on the right, you can see a figure that's come from something that Jeff Cumming produced called the Dance of the P-values that really demonstrates very clearly how unreliable p-values are, how much they dance around. And what you can see here is a sort of a simulation of successive runs of an experiment where there was an actual effect. It was an effect of sort of 10 points, and you might see in tiny writing that's the zero difference line, the vertical line on the left, and then the line showing where that p-value would be given the actual effect size. So the little dots are the p-values, and the whiskers around them are confidence intervals. And the key thing to point out here is that confidence intervals do tell you something that really lets you know how reliable or gives you a good indication of how reliable your finding is. But the p-values themselves are not particularly informative. And yes, as I say, this is very much tied up with statistical power. And what we know contributes to statistical power is alpha. So it's where you set your threshold, the p-value that you accept. It's also effect size. So if you've got a very big effect, that's not going to be so much of an issue. And crucially, it's also sample size. And I think when people have looked at reproducibility and why results of statistical tests don't replicate, it's often argued to be a function of sample sizes, and why sample sizes are and that sample sizes are too small. Okay, so just to think again about how statistics impacts on the research process, here's a sort of figure showing the scientific method, so the cycle of science. So starting at top right, you might come up with some experimental hypotheses that you want to test. You then go out and design a study to address those hypotheses. You go out and collect some data. You analyze the data and you test your hypotheses. You then interpret those findings and you then go and publish them. And then based on your findings, somebody else or you yourself might go out and generate some new hypotheses, and on it goes. So where exactly does stats fit in? Well, it fits in here, right? Yeah, where you analyze your data. But I think what we know is actually that statistics has a much broader influence than that, and can make much more trouble in the whole process than that. So here we have it again. So just to show where statistics can lead to problems. So first of all, when you're designing your study, unless you calculate power and know exactly how many participants you really need to reliably test those hypotheses, that's the first sort of error or potential source of problems that you could find. At the next stage, there's something that's known as p-hacking, which is where you go and collect your data and you just think, I'm just going to go and have a quick look whether I've got a significant result or not. Oh dear, it's not significant. I better go and get some more data. There must be something wrong with the data that I collected so far. P-hacking then continues at the next phase when you've completed your data collection and you don't get a significant result. So you think, oh gosh, something needs to change. I need to run some more statistical tests. I need to maybe look at my data and exclude problematic cases. I might need to do different types of statistical tests. All of these times you run more statistical tests, you're increasing the values of making those kind of errors of inference and reducing the likely reproducibility of the results that you find. Another problem goes on from here. This is what's known as harking. According to the scientific method, you derive your experimental hypotheses and then you go and test them. Harking refers to hypothesizing after results are known, which is when you go and rewrite your hypotheses, having seen what your results are, having seen the results of your statistical tests. All of these are instances of when that p-value is really driving the way you're doing your statistics. And this is where a lot of the problems with the use of statistics have arisen from. At the next phase, it's not all about researchers themselves. It's not just researchers who are obsessed with p-values, it's also publishers. And there's a real publication bias, meaning that if you don't get a significant finding, it's historically been extremely difficult to get your research published, which I think means people need to do everything they can to manipulate their data into that shape that will get them that significant result, because it's so important for their careers, for grant funding, for publication and things like this. So it's a whole the scientific world needs to address this issue in many, many different ways. So what can we do about this? Can you mute? So what can we do? The first thing is not to rely so heavily on p-values. It's extremely important, and I think to report effect sizes and confidence intervals, to use models, not just strings of statistical tests, and then also report how well those models fit our data, or to abandon frequentist statistics altogether and use Bayesian methods instead. But how does this relate back to open research, what we're talking about this week? I think lots of the methods of open research very specifically address some of these issues with poor statistical practice. So pre-registration means that you really specify your experimental design, you calculate and report power before you go out and move towards actual data collection. Yeah, you specify your hypotheses and you decide what statistical tests will be the most appropriate, and you're committed then to using them. So this prevents p-hacking and harking. The use of pre-registered reports is a very effective way to force publishers to publish null findings that can be just as important as other findings. Using open data allows other people to access your data, rerun analyses, check analyses. It also allows people to use your data to contribute to meta-analyses that we know are more robust and reliable, because again, you're collecting data from lots of different samples and you can be sure that you've got something more representative. Open code, as we've been hearing this morning, sharing code, but being very open about exactly how you've analysed your data too, and publishing that, demonstrating how you handled outliers. All of these issues that again can make the way in which you carry out statistics more robust and reliable. So now moving on to the statistics community practice and what that's all about and what we've been up to over the last couple of years. The initial aim was to gather people across all the different academic schools and also key professional services teams to be part of this community of practice. And initially, we've been really engaged in finding out what's going on currently at Reading in terms of statistical practices. So this was to identify areas of real excellence at the university. And at the university, we do have researchers who are really working at the forefront of their discipline in terms of the statistical methods they're using and the way that they're promoting those methods. But we also wanted to find out areas where more training and support is needed to ensure that the research coming out of the university meets the really high standards of robustness and openness that the university is committed to through the research integrity agenda more broadly. And then to look at ways that we can really make changes happen in terms of improving statistics as a way of improving research. Okay, so here's the initial team of people who formed the SCOP. And you can see that schools are very well represented. And we've also had really important representation from professional services teams, as you can see down here from the functions. Okay, so one of the biggest pieces of work that we did in the initial period was to really, as I've said, to really look at what is going on, how people are feeling about how researchers feel about their own use of statistics and whether they feel they use best practice in their statistics. And we did this in lots of different ways. You might remember a questionnaire went out last summer looking at the researchers were invited to contribute to, and that was both PGR researchers and staff researchers. We've held lots of discussions, informal discussions, more formal discussions, workshops and focus groups in schools and in professional services teams to find out how people are feeling and using stats. And I also did a review of Viva outcomes to look at the impact of statistics on PhD outcomes. So just to tell you a little bit about that, the SCOP questionnaire, over 400 people contributed to that last summer, both staff and PGR students. There were some very general questions about people's background and training, whether they use primary and secondary data, how familiar they were and confident they were using open research practices. Then there was a series of questions more specifically really looking at how people felt about their own use of statistics. So looking at levels of confidence in the use of statistics in their own research, looking at the impact of statistics expertise on their research outcomes, so publications, grants, PhD outcomes, and their views on the current state of stats support and training available at Reading, both sort of centrally and within individual schools. And yeah, there were separate questionnaires for staff and PGR students, but there was a core set of questions that we could look at across both groups. And we analysed the data using initially factor analysis, which extracted these 3 different factors. And one really seemed to be about people's confidence with their own levels of skill. The second factor was really about how people felt about current provision at the university and how much that needed to change. And the third one was very much about our PGR students and how well supported they were in their use of statistics. And so having extracted those factors, we then went and looked in more detail at the items that loaded more heavily on each one. Okay, so what did we find? What we found really was that the confidence across the university, certainly in the people who completed the survey, was strikingly low. Less than 40% actually felt they had the skills to use statistics in line with best practice. And there was a strong view that research culture needed to change and provision at the university needed to change. So around 85% agreed that more training, more support, more communication was needed at the university. And we also set forward a few ideas that we had for ways that people could be more supported at the university, and people agreed quite strongly with some of the proposals that we did come out with. There was also a view that our PGR students weren't getting the support that they needed. Quite shockingly, actually, less than 25% actually agreed or strongly agreed that PGR students were getting the training and support that they needed. There are clearly going to be very big differences between schools and between disciplines, really reflecting the very different levels of statistics training that people get at different stages when they are training in different disciplines. But there, yeah, and we found that, different schools and different people from different disciplines felt very differently about the need for sort of more within school level support. For instance, in schools where everybody's very highly trained in statistics, they felt there was, there's just less of a need for it. So it's really clear that there's not one solution that's just going to work across the university, because we all come with such different levels of skill. But even in some of the disciplines where you would have expected people to feel much more confident in their use of statistics, there were still some very similar issues raised. In terms of really ensuring that people are using robust methods, that they're fully embracing open methods in the way that they're using statistics. Okay, and I also looked at PhD outcomes, and I actually looked at Viva reports to look at how often examiners were raising concerns with statistics, and they were raising concerns with statistics often, and a higher proportion, the writing's too small, but where there were major amendments, there were actually, it was more often than not, people were raising concerns with statistics. So again, suggesting that, really bearing out some of the concerns that people expressed in the questionnaire. Okay, bearing in mind we've got very little time. So what can SCOP really do to help with this? And now talking about the next period, the initial funding period's ending soon, but we're very pleased that we have now got funding for SCOP to continue. It's going to become fully integrated with the Open Research Agenda and will become part of the Open Research Action Plan and be managed as part of that. We're planning a launch event in the autumn, and at which point the SCOP's going to open up to researchers across the university. And what are we going to do in terms of providing more support for researchers? We're proposing that the system of SCOP representatives will remain, and in some cases, we're promoting the use of SCOP. The adoption of SCOP champions within schools who will really provide some on-the-ground statistics support for people within their school. We're also planning a couple of really exciting initiatives. One that's been led by Etienne is a cross-institutional discussion forum led by a core group of UK Reproducibility Network members from other universities who are really engaged in statistics. We're also looking at the possibility of setting up a cross-institutional applied statistics service, which is led by University of Reading, but will have contributions from other institutions as well. We've got a website which will provide access to researchers to curated resources, so all types of resources. And I'm hoping that the website will really help with communication, just so that everybody knows where there is training, where there is support available, where they can access it. In terms of training, we're also proposing that there'll be a statistics summer school every couple of years that's led by SCOP. There have been lots of really great initiatives, often led by IDRCs. So SELM has led these, the INFH, if I got those letters in the right order, has also led stats training recently. It's not running this year, though. We're also putting together a central sort of repository of all the materials that's been used for teaching stats. And this is really valuable stuff, particularly post-COVID, where lots of people have got kind of recorded lectures of all the statistics training they've done. So if all of that's put in a central place, it means researchers will be able to go and access really good training materials. And we're also, we've got in planning some ideas about ways that our researchers could receive training at other universities as well. And maybe this could be, again, a collaborative initiative. Okay, so I hope I've convinced you that statistics is absolutely fundamental to all different aspects of open research. And, I think we're lucky to be at a university where these sorts of initiatives are so high in the agenda. And I think Reading's a real front runner in some of these areas. And what we found, though, is that researchers aren't confident that they're really using the most robust methods in statistics, but hopefully SCOP can address that and can make a real contribution to research culture at Reading. That's it. Thank you, everybody. And yeah.